Power supply is attached to the keyboard's base by 6 screws. There's 4 Phillips heads in each of the corners of the metal base plate, and another set between the heatsink and the transformer. Removing those 6 screws will allow the entire power supply assembly to come out of the keyboard. Now the power supply is freed from the keyboard. Disconnect the main power connectors here, these Molex ones. Never attempt to power up the power supply without these connectors connected, because you will destroy the voltage reference amplifier that's on here. Actually, it's an op amp, but without the reference feedback of what the output transistors are doing, the power supply will go full voltage and you will damage the devices on the power supply. The AC power cable enters through a little storage compartment on the bottom and passes through out the left side here. So somewhere it's anchored, so we're going to have to remove this sustain chorus tremolo control panel in order to find out where the anchor point is for that AC power cord. Remove the panel by simply taking out these 2 Phillips head screws on the top, and then the 2 screws on the bottom of the machine. With the 4 screws removed, just lift the panel up and out of the way. This is the bottom side, for those of you who are curious. A lot of labor and hard work went into making these machines. They don't make things like this anymore. Now we have to remove the entire keyboard panel itself to get to the last little section of power cord. In order to raise the keyboard panel, we also have to remove the power switch. 2 Phillips head screws on the top, and again 1 screw located on the bottom. With the 3 screws removed, the power switch can be set aside. Now we have full access to all the fasteners that actually hold the keyboard into the chassis. On the right hand side of the keyboard, start by removing this flathead wood screw, and then the 2 Phillips machine screws. Repeat on the left hand side of the keyboard. Again, another wood screw and the 2 Phillips head machine screws. And 1 final screw, center bottom. With the screws removed, the keyboard slides back and lifts up on hinges. And there's a little prop rod that you use to keep the keyboard in the service position. Release the wire anchors and remove the cable strain relief. Remove these 3 screws that hold the storage compartment for the power cord in place. With those 3 screws removed, you can gently lift the panel up and remove your power cord. Just like that. Remove your ground wire. Now the power supply can be removed from the chassis. It's a little bit heavy. The regulator circuit board is attached to one of the heat sinks, so to get to the board we need to remove the heat sink from the base plate. We do that by removing these 2 screws. With the heat sink removed from the panel, we can see the circuit board, and the components we're going to replace are all these electrolytic capacitors here, 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 and then the 2 dual op amps. These are the components that are most likely to fail with age for this power supply. And if you lose this power supply in your CS80, you can do a lot of damage. Remove the 4 screws. those 4 screws removed, you now have access to the back side of the circuit board. And now you can begin to install the parts kit. Okay, we're going to begin unsoldering the main capacitor. Since the leads are bent, it's easier to take a tool like a flat knife and your soldering iron. Heat up the lead enough to where you can bend it perpendicular to the board. And take your desoldering tool and remove all the solder. And repeat for the other capacitor. The original electrolytic is rated at 5,600 microfarads at 40 volts. There's a third lead that is used for stabilizing the part, mostly for during transport or other. The new capacitor, even though it's physically smaller, is superior. It's an 8,200 microfarad at 50 volt, and it's a 105 degree centigrade part. It has a very long lifespan versus the original, which they probably are failing. This particular keyboard does have a lot of AC hum from the mains power supply, so I believe that it's leaking past these capacitors. There's quite a bit of ripple. So with these gone and these in there, this should quiet the keyboard down quite a bit. So we're now going to go ahead and replace these 2 large electrolytics. And the way they're oriented in the board, the negatives were facing towards the wiring. It's a good idea on this board, since nothing is labeled with silkscreen or any kind of markings. Take several digital photos all around the board so you know the orientation of all the parts, so in case you do remove a part, you don't know how it went in, you'll know looking at your photos. If you get one of these capacitors in backwards, it can be quite a surprise when they explode. It's not a fun thing. So we're going to go ahead and install these 2 new electrolytics now. Insert the capacitor into the board, and if you want, you might want to use a little bit of adhesive once you get these soldered in place to keep them from working loose in the future. Now I'll flip the board over and solder. Go ahead and solder your capacitors in. The solder that I'm using is a silver solder. It tends to be a lot stronger than standard lead and tin based solder. Although it has a dull look to it, it's not as shiny, but physically it's much stronger. Now I'll go ahead and proceed and replace the remaining capacitors. Although the new units are smaller, they are a superior part. These are 10,000 hour rated, 105 degrees centigrade Panasonic Matsushita capacitors. These are probably some of the higher quality units for applications such as this. So I'll begin by making note of all your negative locations on all your electrolytics, and we'll flip the board over and start desoldering.